We're going to finish our discussion of rational expressions by talking about rational equations, basically equations with fractions. The strategy we're going to use in this section is we're going to try to actually get rid of the fractions by multiplying every single term by the LCD. In addition, we're going to have to check our answers, and we're really just going to have to check for one thing. We're not allowed to have zeros in the denominator, and that's because division by zero is undefined. So let's start with an example. Example 1a. I have denominators of 3x and x, so my LCD has to be 3 times x. So I'm going to take the equation that was given to me and multiply every single term, all 3 terms, by that LCD. Multiplying by the LCD allows me to cancel out those denominators. In the first term, the 3x's cancel, and we're left with a 2. In the second term, the x's cancel, we're left with a 3. And finally, 3x times 10 is 30x. This is now with something we can solve. We can combine like terms and get the x by itself. 2 plus 3 is 5. I divide by 30, and 5/30 reduces to 1/6. Finally, we're really supposed to check our answer. However, you really only need to check for one thing. You need to make sure that when you take that answer and you plug it in, you don't get zeros in the denominator. So if I plug 1/6 back into x, into that original equation, I'm not going to bother doing this math to check and see if my work was right. The thing I'm going to focus on is in the denominators, I don't see any zeros, and so this answer is fine. X equal 1/6. Example B has denominators of x plus 2, so the LCD is x plus 2. Thinking ahead to when I'm going to have to check my answer, I notice right now that the only way I could get zeros in the denominators is if x equals negative 2. So this tells me that I cannot have a solution of negative 2. So I'm going to take my equation and multiply every single term by that LCD x plus 2. This clears the fractions. The x plus 2's cancel out, and I'm just left with x plus 2 plus 3x equals negative 6. I can combine like terms, subtract the 2 from both sides to get 4x equals negative 8, and if I divide by 4, x is negative 2. However, earlier we discovered that negative 2 actually doesn't work. If I were to take negative 2 and plug it into that equation, I can see that negative 2 plus 2 is 0, I get zeros in the denominator, and division by 0 is undefined. Therefore, x equal negative 2 cannot be a solution, and that means this particular equation has no solution. All right, let's look at one more example, example C. I'm going to start by finding the LCD, and to help me with that, I'm going to factor the denominators as much as I can. That last denominator, x squared minus 25, is a difference of perfect squares. We can factor that as x plus 5, x minus 5. I'm going to multiply everything by that LCD. In the first term, the x minus 5's cancel, and we're left with 3x plus 5. In the second term, the x minus 5's also cancel, we're left with an x plus 5. And finally, in that last term, the entire denominator cancels with the x plus 5, x minus 5, and we're just left with a 2. So I'm going to get rid of parentheses, combine like terms, subtract the 20, and divide by 4. That reduces to negative 9 halves. Finally, I have to check that solution, and I notice that negative 9 halves is not going to give me zeros in the denominator. In fact, the only values of x that would have given me 0 would have been 5 or negative 5. Because I didn't get either of those numbers, that tells me that negative 9 halves checks out and is my solution. We can also use this method to solve formulas, so basically equations that don't have numbers in them. In example 2a, the LCD would be b plus h. So I'm going to multiply both sides of this formula by b plus h. They cancel on the left-hand side, and I'm just left with c. Nothing cancels on the right-hand side, but we can distribute the a and get ab plus ah. Now we're solving for h, so I'm going to get that term by itself. I'm going to subtract ab from both sides. And then to isolate the h, we can just divide both sides by a. And so there's our final answer, c minus ab over a. This answer can't be simplified. You cannot cancel the a's out because you can't factor. You can't factor the numerator. There's no common factors. That's your final answer. All right, let's do one more example that's similar. In example 2b, the LCD is p. So I'm going to multiply both sides of the equation by p. That gives me p times m equals 2v squared. The p's canceled on the right-hand side. Finally, to solve for p, we divide both sides by m. And there's our solution, p equals 2v squared divided by m. Finally, we're going to take a look at a couple of different application problems in this section. And you do not need to write everything I have written down on the screen. I'm going to erase this in a little bit. But I want to try to explain how we're going to set up our first type of word problem, which is a work problem. And the idea is you have two different people working together on a task. And we're going to try to figure out either how long does it take them to complete a job working together, or perhaps how long does it take each of them working alone. And so the concept is, so ignore the example I have right now, but just imagine, let's say it takes Erin 5 hours to build an engine. That tells us that she can complete 1/5 of the job in 1 hour, and she can complete 2/5 of the job in 2 hours, 3/5 in 3 hours, etc. And so the concept behind these problems is we're going to set up an equation with some fractions, and we're going to have basically two fractions that represent the amount of the job that each person is doing when they're working together. If we take the time it takes the two people to work together, the time they spend working together, and we divide that by the time it would have taken that person to do the job alone, that's going to give us a fraction of the task that that first person can do. If we do the same thing for the second person, the time they're actually working together, divided by the time it takes person number 2 to complete the job, that gives us a fraction of the job that the second person does. And the concept here is we want to figure out when do they get one job done, when do these two fractions actually add up to 1. And I'm happy to explain this pattern in a little bit more detail outside of class. I just don't want this video to get too long. But basically, to summarize, when we have these work problems where two people are working together, our equation is always going to fit into the following pattern. We're going to take the time it takes them to do the job together and divide that by the time it takes each of them to do it individually. And those two fractions have to add up to 1. Okay, so in this problem, it says it takes Joey 9 hours longer than Erin to rebuild an engine. Working together, they can do the job in 20 hours. How long does it take each of them to complete the job alone? So I need to pull out of the problem information about the time it takes them together. Joey maybe is person number 1. Erin is person number 2. The only number I know is the time it takes them together. I'm told that it will take them 20 hours if they work together. I don't know how long it takes either Erin or Joey, but I know that it takes Joey 9 hours longer than Erin. So if I say Erin's time is X, Joey has to be X plus 9. Plugging these values into my equation, I get the following. 20 over X plus 9 plus 20 over X equals 1. I'm going to solve this using the exact same technique we used earlier. I'm going to multiply everything by the LCD, which in this case is X plus 9. In the first term, the X plus 9's cancel out. In the second term, the X's cancel. And on the right-hand side, nothing cancels. So I'm going to distribute, get rid of parentheses, combine like terms, and this time I have a quadratic equation. something with an x squared in it. So I'm going to set one side equal to 0. I really want the x squared to be positive, so I'm going to take everything on the left and subtract it to move it over to the right. That gives me x squared minus 31x minus 180. So I need to find two numbers with a product of negative 180 and a sum of negative 31. Negative 36 and 5 will work. So we can factor this as x minus 36, x plus 5. And so my solutions are 36 and negative 5. However, in this application problem, we're finding times, and the negative solution doesn't make sense. So that means x has to equal 36. So it took Aaron 36 hours to complete the job alone, and it would take Joey, let's see, he is x plus 9, so 36 plus 9 is 45. It would have taken him 45 hours. All right, one more example. The second type of application problem you might see is a motion problem. We're going to set these up in kind of a similar way to how we did in the past. We're going to use the fact that distance traveled is always the rate, or the speed, times the time. And so I'm going to take the information from this problem and put it into a table. Okay, so this problem says the speed of the current is 3 miles per hour. Sean can kayak 4 miles upstream in the same amount of time it takes him to go 10 miles downstream. Those numbers are distances. I'm going to put them into my table. 4 miles upstream, 10 miles downstream. Now it says, how fast can Sean kayak in still water? That's our unknown, that's our x. When Sean is paddling upstream, the water is going against him. The water is slowing him down. So the net result, his net speed, has to be x minus 3. His speed minus the water. When Sean is going downstream, the water is actually speeding him up, and so his speed would be x plus 3. To fill in the third column on the table, we're going to use the fact that if distance is rate times time, if you solve that for time, you would divide by r, so time has to equal distance divided by rate. So if I take the distances in the table, divide them by the rates, that gives me an expression for his time. Time is distance divided by rate. Now to get the equation that I'm going to solve, I'm going to reread the problem, and let's see, Sean can kayak 4 miles upstream, there it is, in the same amount of time. That's telling me that the two times are equal. So I'm going to set 4 over x minus 3 equal to 10 over x plus 3. I multiply both sides by the LCD, and I'm left with 4 times x plus 3 equals 10 times x minus 3. Get rid of parentheses. I put all the x's on one side, everything without x on the other side, and I finish by dividing both sides by 6. So x is 7. That tells me that Sean's speed is 7 miles per hour. All right, that's it for our rational expressions. I know there's a lot of material in this section, so please let me know if you need to see more examples or if you're struggling with any of the homework problems.